Hello, this is Geometry, topic 1-3 on systems of equations for the calculator. Again, this is in the unit review called Review of Algebra, so I may be showing this to my algebra class as well toward the end of the year. We're going to be talking about systems of equations, and so first off, let's go ahead and define what a system of equations is. It is two or more equations of lines. The solution is where they intersect. They can have 0, 1, or infinitely many solutions. So first, let me do the default. And that is that I've got a graph like this, a graph like this, and there's my intersection. That's the solution. Now, if I have parallel lines, then there is no solution. Or if I have the same line, then it is infinitely many solutions. So this is two lines that intersect gives us one, two parallel lines give us none, and a line that's on top of each other gives us infinitely many. So let's go ahead and look at example number 1. It says Mr. Jones' geometry class has 5 more than twice the number of girls than boys. If he has a total of 27 students, what equation can be used to find out how many boys and girls Mr. Jones has? So we know that we have B for boys and G for girls. Now Mr. Jones has 5 more than, so that means plus 5, twice the number of girls than boys. Now I didn't actually put this here because I want to go talk about what we have more of. We have more girls. So the girls goes over here and the boys come over here. Always go back, and before you put the letters in, whenever it says more than or less than or anything like that, figure out what you actually have more of, so that becomes on the side that's not getting added and multiplied to. Now, other equation says that we have a total of 27 students. That means if I take my boys and add my girls, I will get 27 students. So we can solve this. There are 3 different ways that we'll be going about in the notes on how to solve this. But this question just asked, what equations do we need? So we are done. We have our 2 equations. Let's go ahead and move over to example number 2. Now here we're going to be using substitution. To use substitution, you're going to look for a lone ranger. Okay, a lone ranger would be like this X, sitting all by himself. So we want to solve the first equation for that lone ranger, plug that into the second equation, and then find our second variable. So I'm going to go ahead and rewrite this. X plus 4y equals 1. To get the x by itself, I'm just going to subtract 4y from both sides, and I get that x equals 1 minus 4y. I'm going to take and plug this in back into this equation. So wherever I see x, I'm going to put this. So this means 2 times 1 minus 4y minus 3y equals a negative 9. Again, this x just went in the parentheses there. So now we'll distribute. 2 minus 8y minus 3y equals negative 9. Negative 8 minus 3 is negative 11. So 2 minus 11y equals negative 9. If we subtract 2 from both sides, negative 11y equals negative 11. Divide by negative 11, and y equals 1. Well, now, we just take this, and we plug it back into our equation over here. So x equals 1 minus 4 times 1. So x equals 1 minus 4. So x equals negative 3. And so our answer is negative 3, 1. Because we always put our answers in the form x, y. So this was example number 2. Using substitution, if you can find a Lone Ranger, this is the fastest way to solve the problem. Now, for elimination, we need to get some coefficients to be the same. So that means I either need my numbers in front of x to be the same, or my numbers in front of y to be the same. Since they don't, I'm going to have to do some multiplication. I'm going to go ahead and solve for y by eliminating x. So if I can do 2 times 5 and 5 times 2, they'll both equal 10. So multiply everything up top by 5 and everything on the bottom by 2. So 5 times 2 makes 10x plus 5 times 3 makes 15y equals 5 times 5 is 25. Now this says opposite signs, and that will help. So I'm going to go ahead and make this a negative 2. So negative 2 times 5 is a negative 10x. Negative 2 times 8 is negative 2 times 4 is a negative 8y. And 2 times 16 is a negative 32. Well, now we can just add these to make it work. So 10 plus negative 10 goes away. 15 plus negative 8 is 7. So this makes it 7y equals 25 plus negative 32 equals a negative 7. If we divide both sides by 7, we get that y equals negative 1. Well, we take this and we plug it into either of these equations. I'm going to go ahead and use the bottom just because. So 5x plus 4 times negative 1 equals 16. So 5x minus 4 equals 16. If I add 4 to both sides, I get that 5x equals 20. Divide by 5, x equals 4. Again, we want to put these in terms of x and y. So x was 4 and y was negative 1. And so that is our answer. So that was example number 3. Now for example number 4, they're going to talk about how to use the calculator. So to solve these using the calculator, the first thing we need to do is put both equations into this y equals mx plus b. Then we're going to put them into y equals. Zoom 6 just gives you your standard viewing window. You may need to adjust. Okay, you may need to adjust your window if this doesn't show you the intersection. And number 4 says we press second calculate and we want to go to intersect. All right, and then we're just going to hit enter 3 times. So first off, we'll need to solve for y equals mx plus b. So x plus 4y equals 1. We're basically going to solve for y, so I'm going to subtract x from both sides. I get that 4y equals 1 minus x. Divide by 4. Y equals 1/4 minus 1/4 x. So y equals negative 1/4 x plus 1/4. And now for the second one. 2x minus 3y equals a negative 9. Subtract 2x from both sides. Negative 3y equals a negative 2x minus 9. Divide everything by negative 3. Y equals a 2/3 x plus 3. Just solved it 2 ways. Used slightly different methods for both of these. but not that big of a difference. Now we're going to put these into y equals. So we're going to come over here to our graph. We're going to go to y equals, and we're going to type these in. So negative 1 over 4 x plus 1 over 4. I always like to put my fractions in parentheses just in case. And for the second one, we have 2/3 x plus 3. Now we're going to go to zoom 6, which you'll see is zoom standard, and it will graph this for us. And you notice we can see the intersection right here. We do not need to adjust. If we did, we need to go to Window to adjust this. But let's go ahead and move on. To find that intersection, I need to go to Calculate, which is above Trace. So second, Trace. And we want to go down to Intersect, which is number 5. And all we do is first curve, you hit Enter. Second curve, you hit Enter. Guess, you can go ahead and scroll close to your intersection. It doesn't need to be right on it, just close. Hit Enter, and it tells you the intersection is at -3, +1. And so that is using the calculator to solve. Well, we've got one more example, example number 5. And here, they're just asking what is the solution. So I could use substitution to solve, either for x or for y. I could very easily multiply something by 2, so I can either eliminate x's or eliminate y's. I could solve for x, I could solve for y in both equations and see what that gives us. But since I have answer choices, I'm going to go ahead and just plug these in. So 2 plus 2 times 0, well, that equals 2, so check. And now 2 times 2 plus 0 equals 4. Well, both of those checked out. So A is my answer, but I want to go ahead and show you some that don't work. So let's go ahead and try 0 plus 2 times 2. Well, that equals 4. So that's why B does not work. And now 2 plus 2 times 2 is 6, which is not 2. So it doesn't work. Since A already is proven to work, we know that it is not no solution. So this is topic 1-3 over systems of equations. Should be fairly simple. Good luck and have a good day.